Welcome to the Dr. Gabrielle Lyon Show, where cutting-edge science meets innovation and practical application for everybody. This is a very special episode in which I bring you my dear friend, Dr. Jamie Baum. She's an associate professor at the University of Arkansas, and I trained with her at the University of Illinois. In this episode, we discuss some fascinating things that I guarantee you have not heard anywhere else. We talk about the role of skeletal muscle in appetite regulation. Yep, you heard that right. We also discuss perimenopause, postmenopause nutrition, where the science is and where we need more of it. We discuss the different forms of dietary protein and their impact on appetite regulation, so much more. Please sit down with me for this episode with Jamie Baum. Dr. Jamie Baum, welcome to the show. You are currently an associate professor in the Department of Food Sciences, and you are the director of the Center for Human Nutrition at the University of Arkansas. But wait, more importantly, you and we go way back. We go back to undergraduate.
That's correct.
And we both trained with Don Layman, which is amazing. You went on and you've actually done extraordinary things with your career. You've gone on as a PhD in nutritional sciences. You've played a role in industry as well as current research and really educating. Welcome to the show.
Thanks. I'm glad we finally made this work.
Yeah. I mean, listen, I've been asking you to come onto the show for like 2 years.
Yeah. And it's been awesome to see what a rock star you've become.
Well, thank you. And obviously we don't do it alone. I do it with people like you and Don. I am really excited to share you with the audience because when I have a question, I will call you. Oftentimes I will call you. I will say, hey, Jamie, what are you thinking about? Where are we at with protein for women? This perimenopause, postmenopause space seems to be growing exponentially. And, your original research really focused on the role of dietary protein, amino acids, fatty acids, and regulation of skeletal muscle. Mm-hmm. And you are now very interested in women's health, among other things.
That's right. I was actually thinking about this as I was preparing to come here today, because I think one of the first projects, I'm not sure if you helped with it or not, that I worked on with Don was in weight loss in women with higher protein intake. And as the decades have passed and I sit at conferences, I notice that the protein space is really underrepresented. Women are really underrepresented, both in research and as the people doing the research. And I think, that's kind of fueled my passion in these last few years, is to get us more represented and at the table.
Yeah, I think that that's very true. When you, and women in all research, but very much so in the protein and muscle space. Mm-hmm. And there was Emily, do you know Emily Lance?
Yes, we met a couple of times.
Okay, so she is, I think she's not at Galveston. I think she is there. She is at Galveston, and she was talking about how dietary protein recommendations, we don't exactly know why, not based on muscle mass, may be different for women. I don't know where you are with that, or if you've thought about it, or where some of the current research is at around women.
Yeah, so what is it? We've published a few review papers several years ago with Bob Wolf, who's sort of
we all know Bob Wolf, yes.
The mecca of protein and protein requirements. And, the initial work for protein requirements was done in young college age males. That's where the whole 0.8 grams per kilogram body weight protein started. There hasn't been much update since then.
Isn't that crazy? There has not been updates for changing guidelines.
That's right. And I know they recently did a literature search. They're trying to see what's out there. Can the guidelines be updated based on the science that's available? And their benchmark has not moved since these guidelines were created. So it's amazing to me that this hasn't been done. At least with the dietary guidelines, they're recognizing finally that not everyone age 19 and older has the same requirements for protein. But it really just seems that whatever they're looking for in terms of moving the needle on recommendations, the research just isn't there yet to make a declaration.
Do you have any sense as to why? And, Don will tell us, I'm sure, he's expressed this to you, that really it's complicated, that when we make a recommendation for the guidelines, we have to also interface that with the WHO and think about how that affects the rest of the world. And perhaps that's one reason why dietary protein requirements have not increased. I don't know what your perspective is.
I think all of those things are true. I think the studies are also very expensive to do that work, and they're complicated. It requires, use of usually stable isotopes, which are usually which are amino acids with a special label on them that you can trace through the system, figure out if they're going into muscle and how much muscle they're building or breaking down. So those are really expensive, time-consuming, and complicated projects. And I think the number of people you would have to study to get some sort of idea for the general global population is probably massive. And it's just not there yet. But really, most of the data is with healthy young men, or now that we see a lot with older adults, with muscle protein turnover and things like that.
Meaning they're getting increased frequency, increased rates of protein turnover. It seems to be very challenging to keep muscle on them. I spoke with Blake Rasmussen. Do you know Blake?
Mm-hmm.
And Blake was talking about how mTOR signaling, which for the listener is mechanistic target of rapamycin, it's one of the key regulators for muscle protein synthesis, is actually essentially not suppressed, but it's constantly on, and it's moving faster, and the expression of it is increased as we age.
Yeah, I'm not sure with the human work. Some of the stuff I've seen, I think in published papers from Blake's lab, seems that what you see physiologically, so the changes in muscle protein synthesis, or maybe even increasing in bulk or responses to a meal with protein, in humans, they don't always reflect a phosphorylation of mTOR. And where in animals, if you give a protein response, you will see a phosphorylation.
So what do you think what does that mean?
I think we're just complex individuals in our bodies. Nothing is an on-off cycle. I think it was Don one time explaining it to me as a grad student, think of our bodies as on is like 52% and off is something is like a 48%, because we are made of checks and balances. And mTOR is expressed in all the cells in our body. So it's not just something magical that happens in muscle. So I think it's just a hard thing to study.
What are you working on now?
That's an exciting question. So right now, we sort of have 3 focus areas in my lab, all centered around dietary protein or amino acid profiles and how they impact long-term health. So we just concluded a study in postmenopausal women looking at protein supplementation and whether that impacts markers of mood or well-being. So we looked at, profile of mood states, which are things like tension, anxiety, depression, and sleep outcomes. The preliminary data from that study was enough to get us more funding to do a larger clinical trial that we're looking at the impact of higher protein intake with or without physical activity in postmenopausal women, to see if we can really see significant changes over time in mood and sleep. Go ahead.
No, I want to hear what everyone is thinking, okay, well, if I increase my dietary protein, is my mood going to get better? And am I going to sleep better? And what's happening?
So one of the interesting things we saw with sleep, and I've heard from peers that they've observed similar responses, is so when we measure sleep, I'd say maybe more scientifically. So someone goes home and they sleep with a wrist like actigraph monitor on. We don't really see a difference in logged sleep according to what we're measuring. However, women report that they feel that they're sleeping better and that they're getting higher quality sleep, and they feel better in general taking protein supplementation. And there were 5 arms to this study, and this response was really unique to the women receiving protein supplementation.
Why do you think that was?
At first, I thought maybe it was like a placebo effect. I'm taking like a special supplement, so I'm going to feel better.
Yeah.
But this study went on for 4 months. So this was something we saw every month when they came back to report on sleep activity. And we had other groups being supplemented. There was a placebo. So
How did they do?
They were okay. I mean, the control group, so they kept on living. No big change. The first month there's always a change because
Right.
they're excited to be part of a study. But when we also gave participants protein with supplemented with omega-3 fatty acids, then omega-3 fatty acids alone and omega-3 or in a control fat, so just a corn oil with protein. It was really only the corn oil with protein, so the protein plus a placebo, and the protein groups that were reporting this self-reporting improvement in sleep. So I think, our sample size was small. It was finishing up right when we had to shut everything down during the pandemic. But we did some predictive modeling with a statistician. And if we had had this higher sample size, we would have probably seen significant differences in mood and sleep with supplementation. Why that is,
I was
I'm
just
not
thinking,
sure.
it would be really difficult to study. You think about sleep, you think about increasing glycine, one of the amino acids. There hasn't really been to my knowledge, a ton of work on these individual amino acids. I think that they had tried a long time ago with looking at tryptophan and some of these other larger amino acids, but to my knowledge, there doesn't seem to be a lot.
Yeah, so we were actually thinking maybe it's tryptophan or some of these like serotonin precursors that are having this effect. I mean, they were being supplemented with protein, so of course we did see elevated levels of tryptophan in the plasma. But we don't have the mechanism, so we can maybe say there's an association, but we don't know for
Why?
sure or why. At the University of Arkansas, I think by the end of this year or early next year, they will have a new research facility where we will have 24-hour metabolic chambers that we can assess sleep and other things in a very controlled environment. So I hope once we're able to launch that facility and use those resources, we can maybe get some more mechanistic answers.
And for the listener, if you get a result or an association, one has to ask why.
Mm-hmm.
What is the reasoning? What would be the mechanism? I'll give you an example. Oftentimes we hear this myth that red meat causes cancer. And one would say, okay, if that is true, then we should be able to say that there is a very specific mechanism of action that holds up.
Mm-hmm.
And again, that's a myth. We don't know that to be true.
And I think that's a really important point across science in general, especially in nutritional sciences, is that there are a lot of associations. People look at big population data and they'll see, people who exercise or participate in physical activity 5 days a week or more live longer. Or, people who eat more fruits and vegetables have less rates of cancer. But it's really just an association, or there's no, I'm not saying that these things aren't true, but you have to have sort of the mechanism to cause it, to identify cause and effect. So that's where we're talking now, is that it could be tryptophan.
Uh-huh.
It could be maybe they participated in the summertime, or it was before they were on lockdown. So people were still, happy living their daily lives. So personally, I do think there's something there in talking, chit-chatting at conferences and talking to other people about their findings in different populations and observing similar effects. It's just identifying what that is. And that's very hard to do in people, because it does require some invasive measurements that not everyone is game for.
Which include things like muscle fat biopsies. They include things like euglycemic insulin clamps, even isotope tracer studies. Those are robust to do in humans, especially free living humans.
And they're costly.
They're very expensive. What kind of protein did you use? Was it whey, casein, soy? Because I do want to talk about the different types of protein and then their impact on appetite.
Yeah, so in this study, we used whey protein. We picked it mostly because it's easily available. Most people are familiar with it. And we used unflavored whey protein because it was a 16-week study. There's a lot of variations you can do recipe-wise for consuming whey protein. And when you do longer term studies, and some people may say 16 weeks isn't that long term, but you need to do everything possible to make sure that people follow the rules and stick with the diet plan. So we chose whey because of its versatility, and also we wanted a complete protein.
What is the research regarding the various forms of protein, whey, casein, soy, and their impact on appetite and satiety signals? Because one of the things that people really struggle with is weight management.
Mm-hmm.
And one has to think, okay, is it an intake problem? Is it that they can't regulate these hunger signals? Are there things that we can do? We know that protein is satiating. And then on a deeper level, what about the various forms?
Yeah, so those are all great questions. I think a disclaimer, I guess, first, the area of weight management and weight loss is complex and multifaceted. Protein is just one part of that, I believe, of the answer. And I think so. I don't know if a lot of people know this. When I teach undergrads, they're always surprised by this information that there is a hierarchy in our macronutrients. So macronutrients, I'm sure most of your listeners are familiar, or macros are carbohydrates, protein, and fat. There is a satiety hierarchy. So in order to how full these different nutrients make you feel, and this is consumed alone, not with each other. So protein is the most satiating or filling macronutrient, followed by fat and then carbohydrates. So I think that's an important thing to understand, especially if you are thinking about designing a meal plan or dietary pattern that keeps you fuller longer. And so in terms of protein source and type, and I will say, if you haven't had her on yet, Dr. Heather Leidy.
She's coming on.
Okay.
Or she's coming on in November. Yeah.
Okay. She is the expert, I would say, in protein and appetite regulation, especially in adolescence. So I would always refer to her and her expertise first in this matter. So I'm glad she's following me up in this. But, some research has come out looking at not only type of protein, so whey protein versus casein versus soy, and also the amount of protein and how that impacts appetite and satiety. And this is kind of older research. I think it's close to like 10 years old or more. And it was conducted in the University of Maastricht. And they looked at giving people either 10 grams, I think 10 or 15 grams of whey, soy, or casein versus 25 grams of whey, soy, or casein. And they found at this lower amount of protein, they had animal sources of protein were more satiating. It was whey protein followed by casein and then soy. But once they got to these higher levels of protein, appetite response didn't really seem to differ. I think some of the hormonal or molecular responses differed between protein source, but it did not seem to impact food intake at 25 grams, where at this lower amount of protein, there was an impact on food intake.
And you point out something that I do think is really important, that ultimately we're looking for outcomes. And in the literature, you can take this study. I think it was a randomized control. Was this a randomized control trial? Is this the dose-dependent satiating effects of whey relative to casein or soy? Is at the end of the day, there are randomized control trials. And then we have to think, how would that play out in the real world?
Correct.
What can we learn? How can we deploy some of these potential strategies to help people with body weight regulation? And what you were saying is that regardless of the source of protein, whether it was whey, casein, or soy, if it's high enough that regardless, for example, if there was an increase in GLP-1, glucagon-like peptide 1, we've all heard about it. There's, semaglutide, there's all of these agents coming out, but the end outcome for overall energy intake wasn't different.
Correct.
Kind of disappointing.
Yes, but I think it's just one factor. I mean, when I first read this paper, we actually found it because we conducted a study looking at breakfast skipping or young adults or replacing breakfast or protein source at breakfast. I can't remember. It was a while ago. And we saw no difference. We had a plant-based high protein sandwich and an animal-based high protein sandwich, and we wanted to see if there were any differences. And we saw actually differences in glucose response and some of the other metabolic markers. We did not see a difference, though, in appetite. And that's how we sort of looked at this paper, found this paper when we were looking through the literature. But that's just one thing to consider. So, regulation of appetite. But what else is happening? And I think your listeners probably, are pretty familiar with protein, muscle protein synthesis, glucose regulation, and a lot of the other metabolic effects like energy expenditure or energy metabolism, fuel use. So I think that's where you'll start to see some of the differences related to protein source.
And basically, this was looking at very specific markers. It looks like it was looking at glucose, insulin, and GLP-1. And also to note, the way that appetite profiles are analyzed, it's subjective, right? Don't they use a scale?
Right.
They're not measuring CCK in the gut. They're right. I mean,
Right.
It looks like they didn't in these studies. So this is the perception of appetite.
Yeah. And I remember when my first job in food industry, my boss was a expert in satiety and appetite regulation in his academic life. And really at some point as adults, we disconnect what our body is telling us in our signals versus what we are actually eating. So even though our satiety hormones may be elevated and telling us stop eating, we've learned to override those signals and eat whatever we want anyway. So in the research, just because you're seeing changes in like physiological changes in the signals that are telling our brain to stop eating or to continue eating, it doesn't mean we listen to them and that we do those things. So that's where those subjective, I think, measurements are important, because I think you'll see in this paper, for example, and we've seen it in other papers, just because the signals are there, if the people aren't listening to them.
When do you think that dysregulation happens? Do you think that's an environmental dysregulation?
I think it's environmental. I've had several debates about this, and, Heather probably can answer more of the science behind a lot of this thought, is that as we're growing up, we live, like in the United States, for example, in a society of abundance. Our portions are huge. I guess it depends who you were raised by or when you were raised. I was raised by a clean plate parent. You can't get away from the table until you finish everything on your plate. Well, right there is an example of repeated ignoring your satiation cues or your stop eating cues, and you're forcing yourself to keep eating. So I think it's a lot of environment, probably social, your family life, going to the restaurant and being served a humongous portion. And I don't know about you, but if you're out there eating with friends or you're having like a couple cocktails with dinner, it's easy to just keep picking at your plate and going and ignoring what your body's telling you.
Absolutely. And I think that that's where actually being educated, because how do you override brain function? Mm-hmm. You have to at some point be able to surf the urge and tolerate whatever that psychological or even physiological discomfort is.
Yeah, and this is getting out of my area of expertise.
Okay, fair.
But if you listen, like to social media accounts or firsthand accounts, or I listen to like some obesity doctors on TikTok. I think, or just people using these GLP-1 agonists, that is something they are starting to learn. For the first time in their life, their brain is quiet about food. And what is the term? Like food noise. The food noise is turned off. So I know there's a lot of controversy surrounding these medications. I'm not a medical doctor, but what I find fascinating is that for the first time, people, like their brain is turning off when it comes to like internal conversations about food. And maybe another tool that these, medications offer is sort of that learning process. Maybe it's a chance to reset how we think about food and start fresh with like a new relationship and new understanding of our body's needs.
I would say that in our clinical practice, I don't know if you know this, but I have a full active medical practice.
Yes.
I see patients. We also have other providers. Shout out to Dr. Lisa Hunt, one of the providers. And we use GLP-1s and other medications similar for exactly that reason. And it's fascinating because if you were to look on social media, you will hear that these medications inherently negatively affect skeletal muscle. We don't see that in practice.
Okay.
When individuals are robust in dietary protein, especially high quality protein because their appetites are lower, and they are resistance training, we do not see negative effects on skeletal muscle.
So do you see preservation
We
during weight
do.
loss, just like if you were following a higher
We
protein,
do.
energy restricted diet?
We
That's
do,
awesome.
which is fascinating. And I think that if one were to dive deeper into literature, there are positive effects on skeletal muscle from these GLP-1 agonists, which actually you were the first person to bring up to me appetite regulation and skeletal muscle.
Oh, that's
in
right.
in general. I am gonna let you kick that off to whatever level you feel comfortable in terms of talking about it. But again, skeletal muscle and appetite regulation, you were the first person to actually bring that to my attention.
So I can't take credit for that concept. When we were all in lockdown during the pandemic, and I had a bunch of PhD students graduate, and in an academic life had this unique situation where I wasn't really having to mentor anyone, but I was stuck, at home all day. So I just started searching on PubMed, which is, like the Google for science, and just started looking like appetite, muscle, appetite, protein, whatever struck my fancy. I had just gotten tenure a few months before, so I had this freedom to sort of change my focus. And I found this paper or review paper or thought piece by John Blundell, who I have not met personally, who is faculty, I think, in the UK. And he had published work suggesting that it's not traditionally how we would think with overweight or obesity, the fat mass that is driving dietary intake, but the fat-free mass, which muscle is a part of, that's driving food or energy intake. So
we have to pause because
okay.
this is a novel concept that you
Okay.
guys have not heard before. Here's my 30-second routine to improving my health, my gut health, and overall well-being. That is AG1. This covers anything and everything that I could be lacking in my current nutrition plan. AG1 is an evidence-backed multivitamin and gut health and beyond supplement that has uniquely formulated whole food compounds that act synergistically together, making it a highly bioavailable and bioactive product to enhance your health. In fact, I first heard about AG1, believe it or not, from my mom. She called me raving about the supplement, saying that her gut health felt better, her skin, her overall body felt so much better. Guess what it was? It was AG1. And I wasn't surprised because AG1 contains prebiotics, probiotics, gut supporting ingredients to support your digestion, reduce bloating, and keep you regular. AG1 is made with bioavailable ingredients that actually work with your body. AG1 has all non-GMO ingredients and contains no added sugar. And it is also an amazing tool in your toolbox for longevity to help fill nutrient gaps. Just one daily scoop provides whole body benefits. That's right. But you know what? Don't take my word for it. Head over to their website and check out their published research. Thank you to AG1 for sponsoring this episode. This holiday season, try AG1 for yourself or even gift it to someone special. It's the perfect time to start focusing on supporting your body with an easy, delicious daily health drink. That's why I've partnered with AG1. Every week of November, AG1 will be running a special Black Friday offer for a free gift with your first subscription, in addition to the welcome kit with vitamin D3 K2. So make sure to check out drinkag1.com/lion to see what gift you can get this week. That's drinkag1.com/lion. And let's start the holiday season healthy. As a mom of 2 kids, I have always had major concerns with what we cook on and how we store our food. I felt a ton of relief when I started using Our Place cookware and appliances because they are made without forever chemicals. These products do not have PFAS or Teflon in it. In comparison, most of today's nonstick pans contain PFAS, also known as forever chemicals. And I will tell you, the EU plans to prohibit PFAS use by 2025. Now, most cookware brands continue to use these forever chemicals because they are at a low cost. That is why Our Place came out with non-toxic appliances. They have been integrated into our family's life. I strongly recommend that you try them if you are not using them. Go to from ourplace.com and enter my code Dr. Lyon at checkout to receive 10% off store-wide. That's from our place, and use the code Dr. Lyon. They also offer a 100-day trial with free shipping and returns. I will also mention this. It makes a fantastic gift. These are beautiful pieces and they can be used safely. Again, I believe that chemicals used in cooking ware are going to be like what we thought about smoking. We thought smoking was benign, and then we figured out it causes cancer. This, I think, is going to be the same thing. We think that Teflon is benign, but in fact, I think it is going. Are you one of the 80 million Americans impacted by hair loss? I will tell you what, I have gone through it and I've had multiple experiences of losing my hair. So now I always take a multi-prong approach. This includes topical and oral agents. One product I love is Divi, and Divi's first product is a scalp serum that actually improved the appearance and breakage of my own hair quality. And this is one of the reasons I'm so excited to share their formula with you. Now, they have a few key ingredients that I haven't found elsewhere. Copper tripeptide, which is a small protein composed of 3 amino acids to help facilitate a clean and hydrated scalp. That's right. Caffeine. Did you know that? Caffeine is not just good to drink, but it also helps promote thicker, healthier looking hair. Yes, I use it on my head. Tea tree oil, something that I've used for a long period of time. It helps reduce and prevent excess oil buildup. Also in this formula, it has amino acids that help strengthen hair, fight frizz, and reduce breakage for overall hair health. Of course, hyaluronic acid, which nourishes hair, scalp, and it creates a clean environment for healthy hair. Now, Divi also has a shampoo and conditioner line. They have hair vitamins, all of which that I have used. And Divi's products come together to create a full daily solution, whether you are a man or a woman who wants to get to the root, no pun intended, I came up with that, of hair health. So if you want to take control of your hair and your scalp health and do it with clean, science-backed ingredients, as a sponsor of this show, they have offered my listeners 20% off their first order. All you have to do is go to diviofficial.com/Dr. Lyon. That's DIVI official.com/Dr. Lyon for 20% off your first order. You know, my dream for these listeners is that they have access to the best scientists, the most creative thinkers, so that they can go out and think from their own perspective. And so right now, what we see in social media and just in general is that people repeat concepts over and over again. The more repetition a concept gets, the more, quote, truthful it becomes, whether it is relevant or truthful.
Correct.
It is just repeated. And right now, people will say that fat tissue, right? It's the obesogenic model that drives food intake.
Mm-hmm.
But what you are saying is there is literature to suggest that it's fat-free mass that actually potentially influences appetite and food intake.
Yeah, and I think he's just gone back and looked at a lot of studies he has published over the years to create this new hypothesis or new way of thinking. And I encourage people who are interested. The papers I think are pretty easy to read. And they're really interesting. And I think it's in a more obesogenic, like you said, context. But my guess is that it would hold true for a lot of populations. And one of the reasons is that, or one of the foundations for this hypothesis is that muscle is more metabolically active than fat, and that muscle is driving energy expenditure, which is then in turn driving energy intake. And it has to do with long-term regulation, short-term regulation. So it's not muscle that's necessarily regulating our short-term response to the meal. That seems to be just, a feedback loop of we eat, our satiety hormones are secreted, we stop eating. But more about the long-term intake over time is where fat-free mass would play
which is fascinating.
Yeah.
And to be fair, muscle at rest isn't that metabolically active.
I guess you're right. But I think the difference is that when we think of our whole body and food intake, our organs are very metabolically active, but we don't change them. Like we have the same, I mean, I guess, you know, the
I guess there are ways to get a bigger liver, right, Matt?
Yes, there are ways. I was like, you know, there are things we can do to damage our organs, but in general, you know, they're the size they're going to be and they're metabolically active is they're going to take the fuel that they need and they are going to be prioritized over our skeletal muscle. But, you know, we can change our skeletal muscle. We can make it bigger. We can make it smaller, which can then make changes in sort of energy expenditure in the food we eat. And I think even though it's not super metabolically active.
It's kind of mind-blowing, though.
Yeah. But if you think, what is it? A study came out several years ago looking at weight gain, how much Americans gain in weight a year. And I think it's like we gain on average, what is it, 2 pounds a year over our lifetime?
By the way, I have some of these statistics. Are you ready for it? Thank you, Julia Mitchell. Ready? Weight gain trends. Here you go. Midlife women, defining midlife women ages 40 to 65, gain an average of 1.5 pounds per year. Okay, fair. The Nurses' Health Study found women gained an average of 6.8 pounds over 8 years. And 70, here comes the other news, which I think is modifiable. Almost 70% of women reported weight gain during the menopause transition.
Okay. And what is this live that she's looking up this information?
No.
Oh, okay.
Do we want her to be live? That's what Matt's here for.
I was like, wow, that's really impressive.
No,
that
we
she's
have
like
these,
feeding you. These.
Yeah, no, so we're trying to get Matt to be there, but we're working on it.
Because then I read another paper, I think it's in that transition of 20 to 30, which would fit some of these statistics that women gain on average, I think, like 7 to 15 pounds. Where was I going with this? Oh, yeah. So that translates around, what is it, like, say, like 1 to 2 pounds a year?
Yeah, it's
but
about.
If we can change our energy expenditure or our food intake by even just a couple hundred calories or less a day, as it could prevent or at least postpone or mitigate
it could at
that
least
weight
attenuate.
gain.
I agree with that. I also don't think, I don't really know the answer to some of this stuff because, you know, you had mentioned early on, you said, you don't know if I worked on these studies. Yeah. As a matter of fact, guess who packed your meals for your body composition postmenopausal women study?
Was that you?
Yeah, it was me. And guess
thank you so much.
And do you remember the large jugs of urine that they used to bring in?
Ooh, you had to do that too.
I had to do that.
I avoided the lab on those days.
I was the one doing it, and I was doing it on Saturday. Gross, underneath the fume hood.
Yes.
And I was just thinking to myself, Don, and you know I didn't get on that paper.
Oh, that's Don. You should be ashamed of yourself.
Do you know why? He said undergraduates should not be on papers.
Oh, that's old-fashioned.
Old-fashioned. But anyway, to answer your question. But in all fairness, if you go back and you look at the literature, regardless if these women were postmenopausal or not, they were able to change body composition. They were able to decrease body fat. Mm-hmm. They were able to increase lean body mass. And we do have to mention, you know, we're talking about lean body mass. That's not the same as muscle. I call you at least every few months, like, hey, Jamie, what's the way that we're going to be measuring skeletal muscle mass directly? And
I actually flagged a paper. I think it's on one of my 600 tabs open in my browser that talked about It came out recently. Did I send it to you?
No, but
then it's on there.
Who was it?
I can't remember, but it was just some sort of maybe a review article. It wasn't like a method-based paper, but talking about all the methods available for measuring.
Oh, well, you got to send that to me. But we know what they are right now. I mean, basically, people will make statements saying that we are seeing changes in muscle mass, but really InBody doesn't directly measure skeletal muscle mass. DEXA doesn't measure directly skeletal muscle mass. CT and MRI do at a whole body level. We're not routinely doing CTs, and MRIs are really expensive.
Mm-hmm. And not all academic institutions have access to MRIs. And there is a method developed,
D3 creatine.
The D3 creatine, but it is also, you have to have someone on the other end.
Very difficult to do.
Analyze the samples.
Right now, there's only one place that so I do research out of Baylor. Mm-hmm. And we are working on a study. I don't want to give away too much of it. I'll tell you offline because it's exciting. But it is so difficult to analyze skeletal muscle mass directly that for us right now, D3 creatine is not an option.
And we've done it several times.
How's that working out?
Well, it's easy to do because it's only 3 milliliters, which is a very small amount for people to take, kids, adults, whatever. The problem is on the other end. So I'm working with Dr. Elizabeth Borsheim, who is trained by Bob Wolf, a stable isotope expert.
Bob was on the podcast.
Oh, he was?
He was.
Oh, that's awesome. And it's getting the method to work and having the right machines to get it to work. And we think we're really close.
That'd be amazing.
But we did the study 4 years ago, and it's taken over 2 years in the lab to get to a point where we now think we're ready to analyze the sample. So I guess the message is it's not easy, it's not time efficient or cost efficient for the general population at this time.
And because of those difficulties in research, I don't think that we have great answers.
Mm-mm.
That we think that we know certain things, but we just don't. And, going back to this biology of appetite control. And so the paper is the biology of appetite control. Do resting metabolic rate and fat-free mass drive energy intake, which again is really fascinating. And it is going to be interesting to see, because what I'm hearing you say, without saying directly, is that maybe you will be challenging some of these traditional adipocentric views of appetite control.
I think that John Blundell really opened like a new avenue or way of thinking about research, and also about maybe a potential mechanism for protein and appetite regulation. And yet, like you said, changing the way we've thought. One reason I think muscle does play a role in appetite regulation is years ago, I asked Bob Wolf if he had muscle samples from an old study that he would be willing to.
And he was like, yeah, they're in my closet at home.
Yeah, willing to share with us. So we did look at expression, or we looked at these muscle cells for expression of appetite receptors in the muscle cell. So it was a very small amount of tissue. And I got this idea because one of my colleagues at the University of Arkansas, who's actually a poultry scientist, had found expression of appetite receptors on chicken breast, which is chicken skeletal muscle. And I thought, I wonder if that's true for humans. So we did find expression of PYY. We also, but then it was such a small amount of tissue, we ran out. And again, we only looked at gene expression. We don't have protein. We don't know if it translates to quantity of protein in the muscle.
Wait, what do you mean? Meaning?
So we have the genes, and we can see.
No one is, by the way, nobody's eating chicken breast after this. I think that they are going to be I'm already on a chicken breast hiatus after thinking about PYY and orexin expressed in the chicken breast, hard pass.
I mean, I think it's, what's in our chicken has a very similar nutrient composition to our own skeletal muscle.
Okay, fine. Yes.
Not just chicken. Animal protein.
Right.
Folks, that's why.
But the idea that PYY and orexin both are, what would you say? So PYY is released in the gut released in the gut and the brain. I'm not sure. I have to go back and look.
Orexin comes from the brain.
Right.
So I kind of had this idea from these reviews. We analyzed these receptors on
chicken breast.
No, these were on humans.
Okay.
Coming from this idea from chicken breast. But actually, I think we did this gene study before I read this paper from John Blundell's lab. And then we just kind of sat with it around the same time. And we have not published this data because all we have are like the potential for these two like hormones to have receptors on muscle cells. Anna Thalliker-Mercer, who's in Alabama, she published a paper showing that PYY receptors are an expression on human muscle cells. So it kind of validates that it wasn't just like a whim, or we weren't just seeing things.
I mean, this is all about, we're talking about body fat regulation, right? Body fat regulation and kind of this adipocentric view. And even in this paper, they're talking about the term lipostasis, referring to the reciprocal relationship, which this is fascinating, between the relationship of food intake and body fat. And really, this kind of paper is challenging this body of literature by John Blundell is really challenging the a traditional way of thinking that fat-free mass may have a component to appetite regulation. And you and I know that the only person that's growing their liver is Matt, the producer, but everybody else, really, our organ systems aren't growing, but our muscle mass could be.
Yeah. And so that also brings me back, I regained my thought,
Okay,
and to
good,
the beginning
good.
of our conversation, is there this brain muscle crosstalk? We know it exists. People in exercise science have been looking at this connection for several years. And it's a paper I read when I worked for Don as a PhD student, and it was an animal study. And they infused leucine directly into the brain. It, through mTORC1, regulated hypothalamic response. So our hypothalamus is our appetite. One of the things it does is our appetite control center. So when you start thinking of all these things, so we have mTOR, we know it's responsive to the essential amino acids. It exists in every cell. Leucine acts through it to regulate appetite within the brain in an animal model. Now we see that our muscle potentially has receptors for these hormones secreted by our hypothalamus. What is the connection? And so coming back to our earlier conversation, this is one avenue where we don't have funding yet, but I'm putting all my extra pennies into funding like a really brilliant PhD student to use her creative freedom to start looking into this idea. And, it could be something that explains why we lose or decrease appetite with age. Well, we lose muscle with age, our appetite goes down. Is it because there's just less mass, so less, metabolic activity happening? Is it that our muscle quality is decreasing, and so the affinity for appetite receptors is decreasing, or our brain muscle crosstalk is becoming blunted? I think it's really interesting, and I think there's a lot to learn also from this work they're doing with exercise on brain muscle crosstalk to figure out what is this mechanism.
There's one thing for certain that we can take away from all of this. Are you ready for the mic drop moment? Guys, totally not a mic drop moment. Is that muscle is important.
Exactly.
Skeletal muscle, regardless if we understand that it controls appetite, which, when you are ready, I will bring you back on and we will talk all about that, because this then begins to expand the conversation of the impact of skeletal muscle mass on overall health, not just from a energy intake perspective, right? So I'm thinking as individuals age, their skeletal muscle mass declines. Does it have to decline? Are we just very sedentary? Could we overcome biology by doing things that you and I both have learned about? Mm-hmm. And maybe we throw in blood flow restriction. Who knows, right? I don't think that there's an inevitable decline. I think a lot of individuals in the literature are sedentary models or, quote, healthy older adults. And that sedentary behavior is in a disease state in and of itself. Right. Would you agree with that? That's like a diseasome of inactivity, which is what they talk about in Copenhagen. And if we can do everything that we can to maintain the integrity of skeletal muscle, maybe we'll have better appetite control.
Right. And one of the things I've been thinking about, I guess, as I age.
You look great for 25, friend.
Oh, you are so kind. And sort of in my life experiences, so working in infant and toddler nutrition within the food industry, thinking about aging, thinking about postmenopause, where are the inflection points in life where protein and muscle really make the impact? And I mean, I don't have the answer to that, but there have to be pinpoint times in life where we're influencing our muscle health. I mean, maybe it is a day-to-day lifestyle thing of accruing positive muscle, but we don't know a lot about birth to 19 years of age. And this grant I actually just submitted this morning was really focusing on the period of adolescence. And I know we share a mutual acquaintance at the National Cattlemen's Beef Association who had recently hosted sort of a mini think tank on what's happening in nutrition in adolescence. And we don't know, but it's a time of really poor dietary intake. And this is the part of life where we are setting ourselves up to become independent, make our own food choices. And I didn't think about these things when I was 16, 17, 18, or even 19 years old. But is that an inflection point for muscle ensuring muscle health
We
for the
believe
future?
it does. So
Okay.
so myself and my colleague Gerard D'Onofrio, and we have some other colleagues, whether they are physicians or PhDs, and Don as well,
Mhm.
working on putting together a conceptual model of this
Okay.
because we believe that it's important.
Right.
As physicians, we are practicing, we are seeing this in real time. You mentioned something that's critical. We have a lot of parents that are listening to this. Infant and toddler nutrition.
Right.
What can we say about what we know and what we don't know when it comes to protein?
So I am not an expert in infant and toddler nutrition. I will say that my role in industry was really working on like fruit and vegetable intake, so nothing related
Get out
to
of here.
protein.
I'm kidding.
Actually, working on that project was what made me realize that I'm passionate about protein, and that food industry wasn't for me at that time. I am not an expert. I know we've gone back and forth, and I've looped Dr. Elizabeth Borsheim into this.
Because I call you and I say, Jamie, there are no good studies on infant
And then I text
toddlers.
Elizabeth. So,
We got to get her on the
I know she's going
show.
to listen to this because I've been texting her about coming on. So, I mean, I think there's a lot of different opinions about protein in sort of the 0 to 3 age. And I think that's a time of rapid growth in life stages that I don't feel comfortable commenting on. But I think there's other periods after we're out of the complementary feeding stage that could be inflection points for protein or muscle sparing
Or even,
or muscle preparing your muscle.
Yes.
How about muscle preparation is maybe a way
yes.
to think about it. And I think we spoke briefly about this before, like maybe last week. And what we've noticed in our work with children, so some of the work I've published earlier and that we're getting ready to publish is in kids ages around 7 to 17 years old, looking at protein intake at breakfast. And usually we're picking breakfast just because it's the first meal of the day. People are usually eating at home and it's an easy point of intervention. And what we have found is that kids who are normal weight, so usually they're physically active, they're in good metabolic health. It doesn't matter what meal we're challenging them with. If it's one time, if it's over 6 weeks, they have the same metabolic response. And what I mean by that is like the energy expenditure is, so the calories they're burning in response to that meal are the same. The fats and carbs they're oxidizing are the same. Their glucose levels are the same. But as soon as we look at response to a protein-based meal in children with overweight or obesity, we do see differences. So we see more dysregulation after higher carbohydrate meals in kids with overweight or obesity. But as soon as we change the protein, and it's really using sort of Don's initial model of higher protein intake, we're not talking about a no-carb scenario. We're just talking about a 15% change in protein versus carb intake. We see improved post-meal response, regulated blood glucose levels, an evening out of insulin. So it really seems to be as soon as your body is metabolically damaged, whether that's being sedentary, overweight, or active, or a disease, is where protein really seems to make a difference. And I think it's with muscle because like your whole hypothesis, as soon as your muscle becomes unhealthy, personally, I think the rest of you becomes less healthy as well.
And when you begin to think about from 7 to 17 years of age, and we're thinking about, I am truly worried about our children.
Mm-hmm.
I am worried about what is going to happen to them from a muscle perspective. They
Mm-hmm.
are more sedentary. I would say they're tracking along the lines of adults.
Mm-hmm.
I did have a statistic up. I don't have it up right now, but we know that 50% of Americans don't even work out.
Yeah.
Well, where do you think kids get their
I still think that's like
low?
low.
I know. Well, I mean, closer to 72% don't meet the recommendations.
Right.
Of both.
Yeah.
Of the 150 minutes a week, the 2 days a week of resistance training.
Right.
If our children, for all parents out there, kids do not care what you say. They watch you. They
Right.
care what you do. And if we have an increasing sedentary and increasing in obesity in children,
Mm-hmm.
we have to think about how do we design diets to correct their metabolism. It is much more difficult to change a habit that begins in youth.
Mm-hmm.
And metabolic disadvantage in youth. I mean, I don't want kids to struggle that long.
Right.
Think about it. That's
And
a lifetime of struggle.
Like, I'm the parent of a picky eater who also has some sensory issues. So mealtime is, I think it's been a 10-year battle. And what I do prioritize is lean proteins, because when you have a picky eater and someone who doesn't like chewing things, it's finding the right protein. But I am constantly worried about like future dietary habits and physical activity. So, he does a lot of physical activity, maybe not by choice, but I say like,
get down and drop and give me 20.
well, and so, I always worked out growing up because my dad always emphasized the importance of working out. And I think that's the only thing that has protected me into middle age, because I come from a family with a history of like familial diabetes, high cholesterol, high blood pressure. And I've made it to almost age 50, like medication free. And I 100% credit that to being physically active from like a young age.
I think that is your best insurance policy.
Mm-hmm.
When you were looking at the adolescents, and you look at traditional Don's literature, basically there was the food guide pyramid. He would do the food guide pyramid where it was, I think 75% of the calories came from carbohydrates. And then he readjusted it to more of a 40-30-30 model, 40% carbs, 30% protein, and 30% fat.
Mm-hmm.
When individuals increase their dietary protein to double the RDA at 1.6 grams, so this was some of the early work that you did, is that kind of the guideline that you were seeing is beneficial in adolescence? Were you guys thinking about the grams? So if the parents are thinking, okay, well, I have a picky eater, how do I rework a diet or make the best dietary choices available?
So we didn't think of it in terms of per kilogram body weight, because we had a wide age variety, and it's a lot of work and it's a lot of mental gymnastics for a parent to calculate this. And children are in a growing state. So I think it's really hard because, I remember one participant in our study, the graduate students came in freaking out because they thought there must have been an error. In 6 weeks, the participant like grew 2 inches and gained like 7 pounds. So I was like, this is not protein, guys. Like, that's not the magic protein. It's just like growth and development, adolescence, things like that. So I tend to think of it as a percent of energy intake, or even looking at the MyPlate model. If they just want a visual, I think if you build your protein sort of according to just how the government suggests or recommends, that's just a good ballpark. And I think, and you've probably discussed this on your podcast before, maybe with Don, but he was always working within the framework of the dietary recommendations. And I think that's an important thing for people to understand, that it's not an elimination diet. It's, if we look at the higher end of protein intake and the lower end of recommended carbohydrate intake, you can see vast differences, at least in adults, in metabolism and body composition.
And I would always ask him, because I'm on the higher end. He'll say you don't need to go above 1.6 grams per kg, which would be 0.7 grams per pound. But he would also say that there's no danger in going beyond that. And I would always challenge him. I would say, okay, Don, well, why work within these guidelines and these frameworks? And he said, because there's a certain level of evidence collectively, then we can say this can be supported by evidence. While we can have these hypotheses, we just don't have enough information yet. Mm-hmm. And again, now you're talking about decades later.
Yeah.
Which is still his answer. And that really brings me to women and this idea that, as women age, it seems like their nutritional needs change. And I would ask you, because I do feel that you are very interested in this, what role does protein intake play in healthy aging? What would you say to that? And what would women have to do, or do they have to adjust it specifically?
Yeah. And I will say I'm passionate about this. It's like the only time I've ever written a negative comment on social media. And this was a long, long time ago.
Just last week. Last week.
It was actually NPR had been interviewing a dietitian about protein intake. And the answer was it might have, what was the last, was it 2020, I guess, when the last dietary guidelines were released? It must have been in 2020, talking about high levels of protein aren't safe. And
Very
it was
archaic.
so uninformed about the latest science. And I think it had to do with aging and things like that. So that's like the one time I've ever been like, check your facts.
And that was the last we ever heard from Jamie Baum.
And I went dark. No, so
she posted, and then that was it.
And then I've like clearly felt guilt over leaving a negative comment for 4 years. So
what do women?
Can we circle?
Yeah, what do women have to do? What?
So okay, yeah, women in general have lower protein intake than men, and in general, as Americans, we are consuming, I think, what is it, like 13 to 15% of our energy intake from protein, which is pretty far off from the 30 to 40% of like increased protein intake that would get you to that 1.2 to 1.6 grams per kg body weight that is recommended as we age. And I think sometimes, protein becomes scary for people because of, like you were talking about earlier, this misconception. If you repeat something over and over and over again, it becomes a reality where, they think animal protein is now bad for you. We only should eat plant protein, because I think it was with the last release of the dietary guidelines that started to advocate for like meatless Monday, increasing animal or plant sources of protein, but without any sort of understanding or description of what essential amino acids are, or amino acid profiles,
it's
or complete
wild.
proteins are. So I see this in my day-to-day life of really educated women, not in nutrition science, but think now that eating animal protein is bad for you because we should be eating like plant protein, or we should become vegetarians for the planet. And I have nothing against becoming vegetarian or vegan. I just think in terms of protein content, you have to really be thoughtful and intuitive in planning your meals to make sure you're meeting your essential amino acid needs. And it does become more difficult to hit that 1.2 to 1.6 grams of protein. And as you and I are on the same page, to maintain muscle mass, which I think is the driver of living. So when we think of postmenopause, I think I think of it as in a different frame of life. It's about living independently longer, preventing our bones from breaking, decreasing frailty, and being able to do all the things that we've dreamt of doing once we're able to retire. And so this is, I guess it's also personal because I'm approaching that phase of life, and often research is driven by what
we think is
interesting. I think it's really an area that has not been studied,
which is wild, but we're going to see more of it.
And I was reviewing, there has been, I think, a longitudinal study. I think it's called like the SWAN study.
Yep.
That has published some interesting research, but it's not an intervention, and it's not looking at dietary, like increasing protein intake for muscle health and longevity. So, and coming back to your point about, people reporting weight gain with the menopause transition, we really don't know yet. Is that a change in hormones? And I think you do have some connections with women in medicine that probably are more versed in this.
It just depends, right? The science.
Or is it aging?
So I think it's a real challenge because I have my personal perspective.
Right.
And my personal perspective, I cannot find supported by the literature. So I have to be honest about it.
Yeah.
And my personal perspective would be, okay, you go through perimenopause, postmenopause, and you gain weight. Mm-hmm. It has to be something to do with maybe FSH, follicle stimulating hormone, maybe the decrease in estrogen. We know that when estrogen is lower, maybe people might decrease spontaneous activity. And then, of course, there's estrogen receptors on skeletal muscle. But when you control for diet and training, we find that weight gain is not inevitable, mm-hmm. that it is not that all of a sudden you've hit menopause. And maybe there are multiple influences, and maybe some people are more sensitive to weight gain during menopause than others. Mm-hmm. But could it just be an aging? It's just hard for me to wrap my head around because so many women say, I hit menopause and I gained weight.
So I think this is also one of those associations. So we gain weight with age. or we observe as we transition through menopause, there is a weight gain, but we do not know the mechanism. And so that's one of the things I'm really interested in. I don't think that it's not true. But we don't know what's causing this weight gain. So I think I've seen it in myself. I think it's a valid concern, but I think we don't know what's causing it. We know most Americans are, like we've already discussed in this last hour, do not meet physical activity guidelines. We know our diets aren't the best. We know, what is it now, 72 or 3% of Americans have overweight or obesity. So is it lifestyle? Is it change in hormones? And this is why we need, and I think scientists and government agencies are starting to recognize this. This is why we need investment in women's research. And you see that at the national level, at least on all the calls for, like from the National Science Foundation, the USDA, the National Institutes of Health, they are starting to prioritize research related to women and women's health because we really don't know.
We don't know. And I would say that for physicians listening and for people that then go on hormone replacement, their weight doesn't go back. There is no, and these are some of the things that I struggle with, because hormone replacement doesn't necessarily change weight. It is not a standard treatment.
Mm-hmm.
Would increasing testosterone potentially increase lean body mass, again, and or skeletal muscle mass? I would say yes, but it's not as simple as saying, okay, we have calorie restriction. We know that if we increase dietary protein to this, we expect to see this kind of weight loss, because we have those studies.
Right.
We have those randomized controlled trials that control for diet and lifestyle. Right. So it's complicated.
And, with the randomized controlled trials, I think that's also complicated because when we recruit people to participate into research, it's often not the reality of most of the population. Right. So we don't want people who are taking blood pressure medicine or cholesterol. If we are looking at the impact of, let's say, increased protein intake on cardiometabolic health. But the reality is most people who are in the aging process are on some sort of lipid or blood
That's
pressure
right.
regulating drug. We don't want people who have undergone hormone replacement therapy. And this is speaking outside of my expertise, but as someone, I guess, thinking about hormone replacement therapy, people stopped doing hormone replacement therapy for ages because they thought it was unsafe. So we have decades where research could have been done or observations could have been made, but
the Women's Health Initiative really changed people's perspective.
But we don't have the data. And I think a lot of the studies that are done, some of the reasons we exclude people are really giving us a subset of the population that we're conducting research with that isn't actually representative of our current population. So that's why it's really important to understand how studies are done, what are they including, what are they excluding before we start making conclusions and sharing that across.
Would you say that there are certain foundational things from the literature that people could all do to maintain healthy muscle mass and weight?
I used to have a very clear answer on this.
This is what happens when you really get into the research. So it's not always black and white.
Sorry. And now I have, I'm starting to think less about maybe body weight in general and more about muscle health. But without an easy, effective way to measure muscle mass, it's very difficult.
Or muscle health.
Health. Because
and how are we defining muscle health?
We know from the MRI images that do exist in the literature. I'm sure in medicine you've seen a lot more than I have access to. When you look at a cross-section of muscle from someone who is older or with obesity, you do see fat infiltration into this skeletal muscle mass. So to me, that would say it's probably then going to start causing a lot of adverse metabolic effects or increased disease risk. So my theory would be to prioritize healthy muscle, but to get healthy muscle, you have to think about what you're eating and how you're going to grow it and exercise it and feed it the things that it needs, which then should potentially change body weight. But I don't know, in thinking of like the BMI controversy, I don't think it's just to have a BMI 25 and then your muscle or lower, your muscle is healthier.
I absolutely agree with you.
So I guess I'm trying to separate vanity as I age from like physiology and like reality. But you can't have healthy muscle, in my opinion, and based on the science that I've read, without working your muscle and feeding it properly.
Everyone asks me about the magnesium that I use, and it's called Mellow. Did you know that 75% of American adults are deficient in magnesium? I was one of those people. It is a mineral that is essential to hundreds of functions in the human body. That means that 3 out of 4 of you, chances are you are deficient too. And guess what? Magnesium deficiency may be at the root of a whole host of modern ailments. They could contribute to anxiety, depression, insomnia, stress, you name it. Mellow Magnesium is a powerful daily super blend that contains 3 bioavailable nutrient-dense forms of chelated magnesium. I use this, and it has 2 aminos, GABA and L-theanine, and over 70 trace minerals in it. Mellow is truly in a league of its own, and I'm so grateful that they are willing to sponsor this podcast. Now, it comes in 4 delicious flavors. That is lemon, lavender berry, pomegranate, and naked, which is stripped down, as you can imagine, a naked flavor free. It is a great version that you can throw in your smoothie or before you go to bed or even your tea. Mellow Magnesium Super Blend is a full transparency product. It is third-party tested, and all lab reports are available, which I think is really important. I know that you will love this product. I have been using it for a while, and now for the first time ever, Ned is increasing their discount to 20% off with the code Dr. Lyon. Go to helloned.com/Dr. Lyon and use the code Dr. Lyon at checkout. That's HELLONED.com/Dr. Lyon to get 20% off your order. Seen myself, my family using red lights and infrared heating mats and pads. Okay, so we use products from Baum, which is a holistic wellness brand with a huge range of products to optimize your life in every way. It's founded on science and it's inspired by nature. All Baum products adopt ancestral ways of living in our modern day world, which I love. And I feel that balancing our highly industrialized lifestyle is critical for overall health. It is super easy to add in red light panels to your routine, travel lights, clip on your computer, or the red light lamp. Red light can help with sleep and energy, recovery, the list goes on. For me, right now, I'm using it to balance my indoor time. I use the blue light blocking lamp as soon as it gets dark outside, and of course, the larger panels for 10 to 20 minutes each day. Baum has the lowest EMF on the market, and its quality is incredible. In fact, I might just be gifting it to all my friends this holiday season. There's a 12-month warranty on all red light therapy devices. Go to boncharge.com/Dr. Lyon and use the code Dr. Lyon to save 15% off. That's BONCHARGE.com/Dr. Lyon. Okay, it can be tough to find and book an in-network medical appointment, which is medical care that is covered by insurance. And that's why I'm so grateful to our sponsor, ZocDoc, which is a free online service and mobile app that helps patients find and book medical or dental appointments. You can book local dermatologists, OBGYNs, that most importantly take your insurance, and all who are vetted professionals. ZocDoc, the free app and website where you can search and compare high-quality in-network doctors. Choose the right one for your needs, and you can click to book an appointment instantly. How convenient is that? There are more than 100,000 healthcare providers across every specialty, from mental health to dental health, eye to skincare, and beyond. It's super easy to filter doctors who take your insurance and who are local and who are good fit and who are highly rated by verified patients. Okay, so choose a time that works for you. Go and book instantly just by visiting ZocDoc.com. Doc, and you will be able to get an appointment typically within 24 to 72 hours of booking. How amazing is that? You can even score some same day appointments. You have no excuse. That's exactly how I found my local dentist and primary care physicians. So if you are putting off your doctor's appointment, don't, because appropriate screening and care can save your life. Go to ZocDoc.com. That's ZocDoc.com/Dr. Lyon. Sign up, find your doctor, and take care of your health. I would agree with that. And I do think that we're at the cusp of various ways of training muscle beyond strength, hypertrophy, stability, all of the things that we think about. There are going to be various stim suits and radio frequency ways to contract skeletal muscle. I think that we're going to start to see an increase in kind of technologies that will help people overcome this atrophy issue.
I think we're probably in the very near future going to see medications.
Yes.
There's some under clinical trial now to help with preserving muscle loss.
Yes.
So I was at the Obesity Society meeting last year, and they were presenting some preliminary data on some of the, like, I think injectables for preservation of lean mass. So I'm going again in November in San Antonio.
Do you know Faden is going to be there. Faden Makos, he came on the podcast.
Yeah. So I'm going. Yeah. The whole reason I'm going is to see follow-up data what's presented, mostly related to lean mass and the GLP-1 agonists.
It's going to be fascinating.
Yeah, and to see the new drugs that are coming out. And I'm really interested to see what is the medical profession finding and presenting related to lean mass and protein intake. Because last year, I did not attend all of the days, but in the 2 or 3 days I did attend, I only saw one physician speak about diet, like in dietary intervention along with these GLP-1 agonists, about protein and a protein-based lifestyle. And lo and behold, it like you already said and what you're observing in your practice, it preserved lean mass. And actually, I have an undergraduate student that, he wants to do an honors project. So I have sent him around to start asking a lot of these weight loss clinics that are popping up everywhere now, what diet advice are they giving people when they start these? And it is some it's none, or they're just telling people to eat more protein, and then we're asking for a copy of what they're giving people. And I think it looks like my 10-year-old could have copied and pasted facts from the internet and stuck, the fonts don't even match. So I think there's a lot of work to do, especially as a lot of these drugs are still not at a price point that people can afford. And they're not teaching you new habits.
Yeah. And, and I think it's fascinating that they're continuing to look for new drugs regarding muscle mass, as opposed to doubling back on drugs that are used for HIV and cachexia. So there are anabolic agents that are utilized and have already been studied for things like cachexia.
And I would argue, coming back to our discussion about children, is that we have to go even further back and change our messaging and focus on behavior from a really early age.
What about women, PCOS? They often struggle with insulin resistance. Have you studied PCOS and maybe how protein consumption influences insulin sensitivity or any of those things? Have you looked at that?
So I just got a pilot grant to start looking at that. I am not an expert in PCOS. So the piece I bring to the table is the protein, skeletal muscle body composition aspect and sort of metabolic regulation. I got the idea because of a professor I met at Texas A&M. Her name is Heidi, I think, Vandenbrink, and she is more of an expert in PCOS. And I just happened to be giving a seminar at A&M. My lovely host was writing a grant, so she had me visiting people in the department, and we just clicked and started talking about her work in PCOS and the role protein could play. I recommend having her one day if you are interested. She's local-ish.
All right. Let's get her on.
So we started talking about it because of the role of dietary protein, or the regulation of diets higher in protein with metabolism and with cardiometabolic health and the work that we did when Dawn started all these like dietary interventions. So a lot of the issues women with PCOS face as far as metabolism are similar, like insulin regulation, changes in body composition, things like that, a struggle with weight gain. Can we mitigate some of these with protein? And I thought surely these studies must be done a million times over. And there's a position. So Heidi actually shared with me this position paper, and they did a systematic review. Have you ever spoken about what that is? Where you systematically search the literature for research that has been done on a specific topic. So they looked at all the dietary interventions with PCOS, and then usually you set criteria for what makes it a good study or what makes it a bad study. And this is, I'm not sure how large the nutrition part is, but this is a 3,000 page, I think, position paper.
Massive. It's massive.
So of all the dietary interventions, I think like 15 or 20, only 15 or 20 made it, and only one protein and none like in adolescence or early adulthood. So there is some work to be done there.
And hopefully she'll be coming out with more of these studies.
Yeah.
It'll be interesting to see what your pilot study shows. What about in terms of the glycemic control? How would we think about, if we know PCOS, those individuals seem to have higher levels of insulin, higher levels of glucose. It's one of the major causes of infertility, especially with younger women that want to get pregnant for the first time. Is there a role for dietary protein to help with potentially glycemic control and insulin sensitivity?
Definitely, yes. I am not sure. And I guess, in my understanding of PCOS, they don't really know what causes it. It's thought to maybe have genetic roots. Are you more familiar with that? So, but I think one thing I want to emphasize, especially because I'll have young women come up to me after class and start asking me questions. Protein is not your magic bullet. So especially when we're thinking about glycemic regulation, you can't just like eat your normal diet and then start like chugging your whey protein.
I told you, Matt. Why are you doing that?
So this is something that, I guess was ingrained to me 24 years ago when I started working with Dawn, is that it's an exchange. So if you are going to start adding protein to your diet, you need to take something out. And that's usually where to me, it's refined carbohydrates. So it's well established that increasing protein intake while reducing your refined carbohydrates can regulate glycemic response and regulation of blood glucose. I think in almost all types of metabolic dysregulation, with obesity, with type 2 diabetes, with age. I think you have to do it the right way, but also with energy restriction. So it's not eating calories in excess of what your body needs to maintain its weight, but it's more protein. So that's going to it may help your glycemic regulation, but it's not going to help a lot of other things. And just because you have higher protein intake does not mean you can't also have weight gain due to excess energy intake. So this is something I have had students yell at me in class.
That's great. Did you fail them? What happened to them? That's insane.
I can tell you offline because it's sort of a political drama of why I would never argue with a student that's yelling at me at the end of class. But, it's always, well, my trainer told me this, or I saw this influencer on social media. It's not you. It's not Lane. So it's not people.
We never had to deal with this. People don't understand, when we talk about this difference between plant-based and animal-based protein. And, when we were doing research and, you're still doing it, we did not see this huge divergence and this huge emotional charge.
Yeah, food, everyone needs food to live. Food is emotional. High quality protein is also an issue, I think, of accessibility, and people view that oftentimes lean, high quality sources of protein are not affordable or they're not accessible to them. But that has nothing to do with the people yelling at me at class. These are usually young men hitting the gym. And I always call it the N of one science. A former PhD student of mine sort of coined this term in the lab. It worked for me, so it must work for you. And it must be the golden rule because it worked for like the N of one myself. So But I think there's so many nuances. And, it's just like you can't go to the gym and skip leg day and then expect to have like
Jacked
jacked
legs.
legs. So you can't just eat a bunch of protein without
Right.
physical activity, without resistance training, without some energy restriction. If we're coming back to PCOS and issues with glycemic control, and often PCOS comes with weight gain, and expect to see results.
Yeah, and you have to move muscle, right?
Mhm.
You have to create a stimulus where you're also depleting
Mhm.
muscle glycogen. You have to create enough flux for, whatever the metabolites are. I don't
Yeah.
know if we know whether it's ceramides or diacylglycerides or intramast cellular
Mhm.
fat, whatever it is.
Yeah.
You have to exercise to use whatever those metabolites are.
Right.
And when you're not training, body composition management is going to be a struggle.
Yeah. And to me, I always tell people protein is giving you the substrates you need or like the components you need to build more muscle. Protein itself cannot build more muscle for you. And that's a hard one because then you have to put in the work.
Yes. What about, have you found differences between plant-based, animal-based proteins when it comes to their impact on weight management?
So we haven't really studied it specifically in terms of weight management. I know in a conference I attended, I think it was this spring, and Luke Van Loan and Stu Phillips were there presenting some of their data looking at plant versus animal protein in terms of fractional synthesis rate. And they didn't seem to see much of a difference, but I think it also may have had to do with the essential the essential amino acid profile in the proteins they were studying. Again, I think to me they would be comparable in a weight management or weight loss situation as long as you're hitting that protein threshold and that you're ensuring that your protein sources, whether they are from animals or they're plant proteins, they're becoming complementary to give you the essential amino acid profile you need.
I think that the literature supports that.
And I don't think that's something, well, people probably know about or talk about enough within the like social influencing
Yeah.
sphere. If you say complementary protein, someone's like, what? And so I think that's something that has gotten lost in this push for plant protein intake, the need to complement your proteins.
Yes.
It's because it is about your essential amino acids.
And then if we were to take it one step further, the needs, for example, things that ride along with, let's say, high quality proteins, things like iron and zinc and selenium and other micronutrients that
Right.
are critical that may be different in plant-based proteins.
Right.
Yes, there is the essential amino acid need. We can all agree on that. And then thinking about what has the most nutrient density.
Right.
Because, let's say a woman who is a menstruating female, she might become iron deficient. Iron deficiency anemia is a huge challenge. Right? They're all things to consider. And you worked on the SHAPE study, which was protein, omega-3 fatty acid supplementation in postmenopausal women. Can you just give us some of the highlight, any of the key takeaways from that?
So that's the one we did discuss earlier with mood and sleep. But, we did not see changes in body composition.
Which is a little surprising.
But I would say no, because I didn't set this up earlier. It was a weight maintenance study.
It was a weight maintenance study.
With no physical activity, because the primary endpoints in that study were really focusing on mood, like well-being, sleep, markers of we call well-being. Because there's a construct that was started, I think, decades ago called successful aging. And in the last few years, we rebuilt that in the context of what successful aging means to our lab. So, and how nutrition or protein plays a role in ensuring that we age successfully. And so we said, well, part of successful aging is well-being, sleep, quality of life. So that was the purpose of SHAPE study. But we did look at body composition, and we did not see changes. But again, we were just supplementing. We weren't changing the ratio of carbohydrate to
Do you remember
protein.
what the average female gets, around 68 grams of protein a day?
Yeah, and I can't remember. I mean, I can tell you offline because I can look up the data, but I can't remember exactly how much protein they were eating. But the essential amino acid profile, the fasting essential amino acid profile in the plasma was higher than in the groups receiving the omega-3 fatty acids or the placebo groups. So, but again, that was the study where we had to cut short because of the pandemic, and we're reworking that study in a current dietary intervention that's actually funded by the National Cattlemen's Beef Association to look at higher protein diets, which we're just talking, but it is weight maintenance with or without resistance exercise in postmenopausal women to see if we can really see a robust effect.
What do you think it would take for research to really move the needle? I mean, I think that we have a good sense of the impact of dietary protein. I don't think we know enough about muscle. I don't think we know enough about appetite regulation and fat-free mass. I don't think we know, you're talking about these inflection points, infant, toddler nutrition. We can understand that certain things are really important. But if you could do whatever it is that you wanted to ask a question and get to a specific endpoint, what do you think it would be?
So I'll start more general because, as an academic, our quest is to get funding and come up with the novel idea or a different way of thinking than anyone has been doing previously. And so when I started my lab, it's natural to pick up where you were trained. And then I realized, been there, done that. We know, and there are several amazing researchers that you have had on your show or will be having on your show in recent and upcoming months that have done it with higher protein, with resistance training, with weight loss, under type 2 diabetic measurement. So I think I think it's safe to assume or generalize that increasing percentage of protein in the diet can help with what we've already talked about, maintaining lean mass, targeting fat loss, appetite regulation, glycemic control, things like that. But I think to move the needle and where I'm taking it is what else does muscle do beyond strength, beyond, clearing glucose from the blood? What are we missing? As scientists and as experts, we know that it's really important, but why? And so that's where I'm putting all these extra thoughts I have into defining mechanisms around muscle regulation of food intake or muscle brain crosstalk in terms of nutrition and aging, not just in terms of exercise. So I think so you see a lot of gut brain axis or fat gut crosstalk. No one ever puts muscle in that mix. So I think,
why do you think that is?
I guess it's not the sexy organ right now.
It is the sexy organ though.
Because gut microbiome, it's still having its
Suzanne Devkota, yes, we've had her on. Also came out of Don Lehman's lab.
And but what about muscle? So I don't know why people sort of, I think, decentralize it, but I think muscle brain interaction is where it's at.
Do you think it's because skeletal muscle is hard to measure, even just from a biopsy perspective? For example, we could take a punch biopsy of my quad, your quad, and Matt's quad. It would be different.
Right. And it will hurt.
And we would don't be such a wimp. It doesn't hurt.
We'd be left with a divot. I think that's part of it, but I don't really think that's the issue because of animal models.
What do you mean?
So a lot of this gut microbiome work, a lot of the other brain work, it's all done in rodent models to get the idea or the preliminary data, proof of principle ideas. I think we could answer it or begin to define some of the mechanisms using animal models. I think in humans, yes, it is a difficult, at least, with some of the gut studies or, you can get a sample maybe daily. In a pretty,
exactly. How are we doing that? Gross. You'll have to get back to me on that.
Okay, but yeah, like you said, we don't have a clear way to measure muscle health. We don't have an easy way to measure what's the flux in and out of muscle. We don't have an easy way to visualize muscle. But I think if more people talked about it, maybe and you need money and investment and capital to develop the technology and to move forward because that will lower the cost.
Yeah, it's going to be really fascinating. I agree with you. I do think it's decentralized. And when we look at skeletal muscle, it's in very discrete groups. It's in, we've had lots of exercise physiologists on. They look at muscle from a performance perspective. And then the aging group, which I would consider myself part of as a trained geriatrician, we think about it in terms of how do we protect and maintain skeletal muscle for many of the issues that you talked about. And then, really centralizing the concept of skeletal muscle as this organ system, which I think that you're beginning to bring up, is this: what is its effect on the brain?
Yeah.
What is the inter-organ crosstalk from exercising to sedentary muscle? And,
Right.
It's...
Well, and like muscle requires work. So maybe it's because I like you're just voicing out loud my internal daily monologue. And what keeps me up at night is that to see changes in muscle mass, it's not just eating.
No.
It's not like having a good night's sleep. You have to put in the work. So no matter what we eat or whatever we're intaking in our diet, it really is just serving as the substrate or the fuel for what our muscle is going to do. But to have our muscle perform, you have to exercise it.
And I think what also that we're beginning to see is that potentially there is, and I've also been thinking a lot about this, and I reached out to Faden about this idea of type 2 diabetes, which we're starting to see more of, and obesity. And do those individuals have skeletal muscle that has the same response to exercise? And
I think so John Blundell, who we've talked about already, who came up with this sort of this theory of muscle driving food intake or appetite regulation, or fat-free mass, I should say, not muscle. And I think he's very specific to not call it muscle because the data isn't about muscle.
I know. It's not on. I noticed that.
Because I've looked through his papers a million times for the word muscle. Maybe he has a way that he's not sharing. But I want to say that it's him. So I'm sorry if I'm quoting the wrong person. But when I lived in the Netherlands, I went to a conference that he spoke at, and it was about exercise responders versus non-responders. And I think he did a lot of this work, because I think some of the science is not old for us, but old for newer generations. A lot of this core foundational work has been done 20 or 30 years ago. So there are some answers about like who's going to respond or not. And they may have even identified some genes of responders versus non-responders. And I have been, maybe one of your followers can find this information. I swear that at some point, 10 to 20 years ago, when the Human Genome Project was coming out, I swear they identified a gene that would make someone a protein versus a carb responder. And I cannot find that paper to save my life. But in the end, it didn't matter.
And right now in the medical space, there's a lot of, there's traditional medicine, and then there's preventative medicine, and then there's lifestyle and precision medicine. And there are many providers that will look at, we've gone back and forth in our clinic. Do we look at individual genes? What does that collection of genes mean? What does that collection of genes mean? And I just don't know if we're there with the data, because
and I think that's
I just don't think we're there.
The challenge. And I actually don't know, because precision nutrition, personalized nutrition, precision medicine, all of these are hot topics. And I do agree that tailoring recommendations to meet individuals' needs are going to help with compliance and things like that. But as we came back, like at the very beginning of this discussion, just because like you have one gene, like we were talking with mTOR, our bodies are a series of checks and balances. So I remember this paper where these protein responders versus carb gene people, that they should have lost more weight, right? If you were following a higher protein diet versus a higher carbohydrate diet. And then I think they switched the people and it didn't matter. And I think it's because we have so many checks and balances. And there's so many other environmental things that we have to set ourselves up for success with, that it's multifaceted. And like there's never going to be one magic answer, except we know from muscle, you need to give it fuels, essential amino acids. We find them in protein, and you need to work it out.
Well, Dr. Jamie Baum, I'm so grateful to have you on. You are really paving the way with these thoughts. And I know that academic research is hard, and there are many roadblocks and challenges, but you're doing an amazing job. And I'm so grateful that I call you a friend and can call you with questions. And, whether it's amino acid questions or various other types of consulting questions, I am so grateful. And I would say I will link people where to find you, which is we will put your, I think it's a Google Scholar link. And then if people want to email you, we'll link your professional University of Arkansas email and kind of homepage. So thank you so much for coming on.
Thank you and I'm glad we finally made this work.
Yes.